Question number 22. A battery of 100 volt and resistance of 10 kilo ohm are joined in series. So this is battery and there is resistance 10 into 10 to the power 3 ohm and battery is 100 volt. Now the system is used as source to supply current to an external resistor R. So there is external resistor R here. If R is not greater than 100 ohm, the current through it is constant up to 2 significant digits. Find its value. This is the basic principle of constant current source. So let's evaluate it. So here we find I. This is 100 volt divided by resistance is 10 into 10 to the power 3 ohm. So this will give 0.01 ampere or 10 milliampere. Here we have assumed that there is no external resistance. Now suppose we take this resistance R equal to 1 ohm. In that case, we find current. Suppose this is I1, this is I2. So 100 divided by 10 into 10 to the power 3 plus 1. So it will remain same 10 milliampere. Now suppose we increase the value of R to 100. So current will be 100 volt divided by 10 into 10 to the power 3 plus 100. So this time the value of current would be 0.00099, which will be equal to 0.01 ampere or 10 milliampere. Question number 23. If the reading of ammeter A1 in figure is 2.4 ampere, then what are the readings of A2 and A3? The figure is like this. This is A3. There is a resistance of 10 ohm. Then there is a resistance of 20 ohm. And here there is a meter A1 and there is another resistance 30 ohm and a meter A2. In our question, reading of A1 is given. So A1, suppose current through this branch is I1 and through this branch is I2 and here it is I. So I will be sum of I1 plus I2. So here we find potential difference across this resistor 20 ohm. So it would be V equal to IR. So I1 is 2.4 ampere times resistance is 20 ohm. So this will give 48 volt. Since 30 ohm resistor is also parallel to 20 ohm resistor, so same voltage will appear for this. So we can say I2 into 30 is equal to 48, from where we get I2 equal to 1.6 ampere. So since I is sum of I1 and I2, so I will be equal to here I will be reading of A3 and I2 will be reading of A2. So I equal to 2.4 plus 1.6, that is 4 ampere. Question number 24. The resistance of the rheostat shown in the figure is 30 ohm. The figure is like this. There is 5.5 volt battery and there are two resistances. This is 10 ohm, another one is 20 ohm, and then there is the rheostat, variable resistance, whose resistance is 30 ohm, and here there is a meter, and resistance of rheostat can be varied. So two cases we will consider when this rheostat is completely excluded and when rheostat is completely included. So case one, when rheostat is completely excluded. In that case, only these two resistances will play their role. So 1 upon Rp will be equal to 1 upon 10 plus 1 upon 20. So this will be equal to 20, 2 plus 1. So Rp equal to 20 by 3 ohm. Now we can find the current. So I will be equal to 5.5 divided by 20 by 3, that is 5.5 into 3 divided by 20. So this will give 0.83 ampere current. Now, case 2, when rheostat is completely included, it means 30 ohm resistance will be in series with resultant of 10 and 20 ohm. So total resistance this time will be 20 by 3, which is equivalent resistance of these two, plus 30. So this will become, this is 6.67, 36.67 ohm, and then we calculate the current. So I in this case will be 5.5 divided by 36.67. So this will be around 0.15 ampere. Question number 25. Three bulbs each having a resistance of 180 ohm are connected in parallel to an ideal battery of 60 volt. Find the current delivered by the battery when all the three bulbs are switched on, when two bulbs are switched on, and when only one bulb is switched on. The cases can be discussed by drawing the diagram. So diagram is first bulb, this is switch S1, and its resistance is 180 ohm. There is another switch S2, and this is second bulb, same resistance 180 ohm, and then there is switch S3, and here there is bulb of same value 180 ohm. These three are connected in series, and there is a battery of 60 volt here. Now, when all three switches are on, in that case, there will be three resistances of 180 ohm each. So Rp will be equal to 180 upon 3, that is 60 ohm. In this case, current I will be equal to, suppose this is case number A. So I will be 60 volt divided by 60 ohm. So that will be 1 ampere. Now, when switch S1 and S2 are closed and switch S3 is open, in that case, this 180 ohm will not be included. So only two resistances will be there in parallel. So equivalent resistance will be 180 divided by 2, that is 90 ohm. In this case, current I will be equal to 60 divided by 90. So 2 by 3 ampere. Now, case number third, when these two switches are off and one switch is on. So only 180 ohm resistance will be considered in this case. So R will be just 180 ohm, and the current in this case will be equal to 60 divided by 180, which is 1 by 3 ampere. So that is our answer. Thank you for watching.